All right, let's do something just a little bit different, not much, but and then we're going to see how it all works together, okay, with a triangle. So I'm going to do something that may not look like what we talked about. Watch, here's two lines. What do they do to each other?
Bisect.
Do they bisect?
Cross.
Now we don't know anything about them bisecting, right? Because I haven't written that in there. Bisect means it splits it into two equal segments. Yeah, two equal segments. Now a lot of people say split it in half. I don't like to say that. I like to say splits it into two equal segments. Let me try to get that right there. That's perfect. Now watch, these are all lines anyway. So can you bisect a line?
If you wanted to.
No, you can't. No, you can't. Well, God can do anything He wants.
God
I'm saying
is
us.
bigger than
Shh. Settle down, please, okay? All right, it's not always funny, okay? Sometimes it just gets irritating. So watch. Let's call this line A, line B, and line C. Those are our three lines. Now, what do they all do? They don't bisect each other. We can't say that because they're all lines. And plus, we don't, I mean, even if they were line segments, I haven't marked anything as far as them being equal, have I?
No.
So I couldn't say they were bisected each other anyway, even if they were line segments. But I can say they do what?
Cross.
Intersect. They intersect each other at what?
Point.
At one common point, okay? In one common point. Now, when we say we have three lines that intersect each other at a common point, we have a name for that, of course. Got a name for everything, don't we? We call those concurrent lines.
Concurrent power.
You think it's bad for you guys, just think what our Korean friends are going through. I mean, you're just trying to learn basic words anyway, and then you got to learn all these crazy geometry words. Oh, I know. But I'm saying, it's a little more difficult for them than it is for you, because you grew up hearing lots of words, but probably none of you had heard this word concurrent before. I'm not really sure. So anyway, here we go. Concurrent lines. No. This is not story time. I'm in the middle of talking and doing a lecture here, all right? So you don't start your story on your own. So here we go. We got concurrent lines. That's what they are, when all three lines intersect at one common point. This point right here, where they intersect, we'll call it P. We call this the point of concurrency. Point of concurrency. So you need to know this vocabulary because they'll talk about it. They'll say, well, the point of concurrency is blah, 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 blah. And we are going to talk about that here in a second. All right, so you got to know that stuff first before we talk about the next little topic here. Everybody clear on that? Pretty easy. Just lines that intersect each other in one point. They all intersect each other at the same point. That point's called the point of concurrency. All three lines are called concurrent lines. That's easy. Let's move on to what we really wanted to get to today. Okay, we're going to talk about a word. I'll put the word up here first, and then we're going to show you where this point is and what that word means. It's called the circumcenter. Okay, circumcenter. Now we're going to learn about how many? I don't know, maybe 4 of these different things. This is the first one. Okay, remember, this is the first one of these that we're going to learn. And we're only going to learn one today. In the next day or two, we're going to learn about 3 more of these things. And you got to remember what word goes with what situation. Okay, when I talk about our situation, we just finished talking about perpendicular bisectors, didn't we? So what we're going to do is we're going to take all 3 of these sides and we're going to draw the perpendicular bisector to all 3 of these sides. And you're going to see something that happens, which is kind of cool. Now, we might have to eyeball a little bit, have to fudge a little bit at the end, but hopefully we'll get this right. Now, I clicked on it like this because I want to, whoops, actually, let's do that again. So it looks about right there, doesn't it? The midpoint. So there, that's a nice way to do that, isn't it? So there's our midpoint. What I want to do is I want the circumcenter goes with perpendicular bisectors. So let's write that out. Perpendicular. If I take the perpendicular bisector of each side of this triangle, I'm going to get a point, and that point is called the circumcenter. Okay, the perpendicular bisector. Remember that. Remember that the perpendicular bisector goes with circumcenter. You follow me? Yep. Because you're going to have like 4 of these to remember. This is the first one. So remember, to find the circumcenter, you have to do the perpendicular bisector of all 3 sides. So that's one side. Now, I did draw that horizontally, so I should be able to get this pretty accurate. I'm just going to draw, and I'm just going to take it to the other side of that triangle. So this right here is now a perpendicular bisector. Would you agree? That's the midpoint. That's perpendicular. That right there is a perpendicular bisector. Let's do the same thing with the other two sides. So let's come over to this side right here. Now, I'm going to have to eyeball. If I connect those, would that be in the center? Probably. Does that look center?
That looks about that.
Okay. So now, actually, let's go with a line. I want to draw a perpendicular. Now, again, I have to eyeball this because I don't really know if it's perpendicular. Does that look pretty much at a right angle?
Yeah.
Pretty close. Might not be exactly.
Hey, that's purple.
That's red. All right, so watch. I made sure that was in the middle so that these two sides are equal. I made sure that that was perpendicular. So guess what this is? This is also a what? Perpendicular bisector. Now they intersect. Now look, any two lines that aren't parallel are always going to intersect, aren't they?
Yeah.
All right. The key is to get that third one. All right, and that's what's going to happen here. So watch.
Because it's going to do like right
If we
there.
do this correct. So it looks like about right there. I think it's right there. Okay. No, I think it's right there. So let's go red. Now watch. I'm going to go perpendicular to this AC, and watch what happens. Now, again, I might have to fudge a little bit because I know what's supposed to happen. But if I used graph paper or a ruler or a protractor, I'd be a lot more accurate on this. I'm just eyeballing about right there. Okay? Now watch. What did I do? I made sure that that segment was equal to that one because that's the midpoint. And I also made sure that this was perpendicular. Do you see what I just did? I drew perpendicular bisectors of all three sides. And guess what they did? They all intersected right here in one common point. Okay? So they're concurrent lines, aren't they? All right, they're concurrent lines, but this particular one, if it's in a triangle, this right here is absolutely called the circumcenter. You guys already nailed that. Okay, it's a circumcenter. But big deal. So it's a circumcenter. Who cares? Well, this is the cool part about this. If I take the distance from the circumcenter to the three vertices of the triangle, watch. If I stretch that out to there, and then I took this and I did what? Stretched it out to there. Now again, this might not be 100% accurate, but it should be pretty close. And if I stretch that out to there, that's right. What do you think is true about those three blue lines right there? They're congruent to each other. Okay. Let's see. I think I might have a... Do I have a little tool that tells me the length of it? Select. No. I think... I don't know. You know, if I don't know. Let me... If I just click on it, I think that tells me 200, around 292. Now again, don't hold me if it's off just a little bit, but it should be pretty close, okay? So that was 292, right? And then look at that, 292.04. That's perfect.
Whoa!
That's,
Okay.
they don't look the same.
And then,
Just 'cause they're going
am I actually pointing on that? Maybe I'm not doing that right.
Whoa!
I don't think I'm doing that
You're
right.
not doing it.
I don't think I'm doing it right.
Click it all the way on the white side.
Click it here. Yeah, because if I click it here, it's 292. Yeah, so I didn't think that was doing it. I thought, anyway, just believe me, all right? That this, all three of those blue lines would be equal to each other, all right? Which means the circumcenter, listen, is equidistant from the three vertices of the triangle. You follow me? So that's the same distance to here as it is to here as it is to here. That would work with any triangle, not just this particular triangle. That works with any triangle. It's kind of interesting. All right. Sometimes, though, that circumcenter may not actually be on the triangle. If you did an obtuse triangle, listen to me. If you did an obtuse triangle, that circumcenter is actually going to be off of the triangle. All right. If you did a right triangle, that's actually going to be right on the triangle. The circumcenter will be on it. If it's an acute triangle, which we have right here, the circumcenter will be inside the triangle. Okay? So you could actually do that. They give you examples on page 324. We're not going to do it. If you look at page 324 at the top, they give you three examples. If you have an obtuse triangle or a right triangle, that circumcenter will either be on the outside, on it, or inside, depending on what type of triangle you do this with.
It's on the outside.
Okay?
Why don't they call it the circumcenter?
Don't know. Well, it's kind of like, you ever hear of the center of gravity? You've heard of that, haven't you, in science class? You ever hear, they even have a commercial out that talks about you know, the car with the best stability is the one that's something about center of gravity and that kind of thing. There actually is, depending on your situation, you could have the center of gravity out. Listen to me. You could actually have the center of gravity outside of the vehicle or outside of the object. It's not always right on the object or in between the objects or something like that, okay? I'm not going to get into that because I really don't know a whole ton of stuff about the center of gravity, but look it up about center of gravity, and that will have a lot to do with the circumcenter, okay? All right, that's it. Let me give you some problems to work on, okay? Now, we didn't completely finish section 5.1, and I didn't plan to. I planned to do it in 2 different days. So this is kind of like the first part. So we're going to call this section 5.1a.
But 5.1a, you just did that one before.
Now, this is what you're just going to name the lesson. You're just going to name this lesson 5.1a. All right, and it's going to be page 327, and you're going to do 9 to 20. All right, so there it is. Okay, so call it 5.1a. When you turn your homework in, that's what you're going to call it. And then it's page 327, you're going to do 9 to 20. And then tomorrow we'll finish up section 5.1. Okay? That's it. Anything you want to say?
I love you guys.